Okay, so let me start the real lectures. Module 1 is to introduce basic MATLAB programming. Here's the indented learning outcomes. At the end of the lecture, you can write an assignment statement to define the variable and assigning the value. You can also define a valid variable name acceptable in MATLAB. You can also explain what is the data type and typecasting process. You can also explain the numeric, logical, relational operator. You can compose the expression using this operator. You can evaluate the expression in the case where there are many operators following to the operator precedence. You will learn some basic math function, and also you can evaluate those functions. Finally, you can understand the concept of the random number, and you can generate the random number using the built-in function. Okay? Alright, so variable you can think as storage, that you store a single and multiple value. A way to put this value in the variable is assignment statement. General form is variable equal sign and expression. So once we run this statement, the value from the expression is assigned to the variable. So this equal sign is not equality. Okay? You can consider this equal sign as assignment. Okay? I'm telling that more than 10% of students make this mistake in the exam. In our courses, quizzes. Also, in this assignment statements, order is very important. Variable always placed in the left-hand side here. Expression is placed here. By the way, what is expression? Expression is kind of the process to compute the value or the value itself. Okay. For instance, here A1 is a variable and equal sign, and 3 is a value itself, or you can put the expression here. Okay. And then 3 is assigned to the A1. Okay. Once we write this script and then run, you will see this variable in the workspace. Okay, here, this symbol of percentage is a put comment on your script. The line after this percentage is completely ignored when the script is executed. So include these types of the comments that help you and other people understand what the script does. Okay? So I highly recommend to put this comment in some kind of important operation in your script. Okay? Right. Here's the naming convention of the variable. All name must begin with a letter, not number. Okay? Can only contain the letter, digit, and the underscore underscore in the only symbol that we can use in the variable name. Okay, so this, you cannot use other character or symbol except for the underscore. Do not put the empty space. Students also make a mistake here. In the variable name, no space, okay? MATLAB is a MATLAB variable is a variable in MATLAB is a case sensitive, meaning that, for instance, your variable is 1, variable 2. These two are the different variable. Okay. Also, I highly recommend that name should be mnemonic, meaning that you and other people know what you store in your variable, and then they roughly guess what it is from the variable name. So clear is a function to delete the variable in workspace. We will see them. We will see this function later. Okay. Okay. So here's some sample variable name. First case is start with the numbers, so there's an error. Okay. This is an invalid variable name. Okay. This start with underscore, not letters. There's an error. This is a fine, right? Start with a letter, but only the underscore is a use for the variable name, right? But these are the at character, at symbol. So this symbol is not allowed in the other than underscore in the variable name. Okay. What about this one? ASDF1 love AAA3. You know, based on my experience, some students is to write a variable like this. You know. Okay. I really don't like this kind of the variable name because it's not mnemonic. I don't know what value inside of this variable. So I recommend that please use the mnemonic variable, meaning that you need to use the meaningful variable name. Okay? Here's the quick questions. If you run this script, what is the value inside the variable name is GA1? Answer is nothing, right? Why? Because the variable name is a case sensitive. So this variable is not defined in the assignment statement in here. Okay. All right. Another example is that this is the question in the midterm last year. Which of the following script has an error? First one, no error, right? Start with the letter and no symbol used in here. This is error, right? Why? Start with the 4. This one used to this so symbol other than underscore. This one as well, right? Error. Okay. What about this one? Is a correct variable name. Here's the expression to compute the value. In this case, these are the 12, right? So 12 is assigned to the JSON. Okay. Good. Okay. So variable do not exist unless you define them. However, there are some variables that are already defined in MATLAB that are constant. Values in the constants are predefined. For example, pi 3.14, that's the pi, right? No, it's the value. I and j is indicated imaginary number. I and f is infinity. And AA is not a number. For instance, the result of the 0 divided by the 0, this is not a number, right? This is not. Okay. The one thing is you need to keep in mind that constants also the variable. I don't know why MATLAB is made a constant as a variable, meaning that you can overwrite or to change the value inside of the constant. For instance, you can run this script, pi is equal to 3, there's no error. And then 3 is assigned to the pi. But I'm not recommending this overriding the value onto the constant. So I and j here is a very common iterator in the loop statement. We'll learn about what is loop statement later in most of programming language. However, I and j is already used as a constant here. So I normally used II or JJ as a iterator in a loop statement. Okay, we'll learn about that later. Okay, all right. So you can modify the value in the variable. Here, although you assign the 10 in the beginning in this line, and then you can modify the value. Okay, how? So see this script. So the meaning of this script is, if you put this variable here, the right hand side, it means they only read, access the value inside of this variable. So in this case, it's 10, right? So this line is performed. First is execute the expression. Expression is 10 plus 3. So these are the 13. So 13 is assigned to the variable, my variable. Okay. Once you run this script in the workspace, you will see this. 13 is assigned to my variable. Okay. Second one is you can define as many variables as possible. Here, I defined the 2 variables. You can also add a variable. You can add a variable in the expression in the assignment statement. So like here. Okay. This is the same with this one. Okay. Because it's access the value inside of my variable and the variable. Okay. Oh, this is not variable. This one is a value. Okay. Actually, it's a val, right? Anyway. Okay. This is an example how to swap the value between 2 variables. Okay. Think about how to swap this value. Okay. Intuitively, the people try to write a code like this. Variable 1 equal to, not equal to, it's equal, but it's not equal sign, right? So too big. Variable 1 equal my variable 2, my variable 2, my variable 1. Do you think it works? No. Why? So see this? This is script. You first access the value inside of the my variable 2. That is a 5, right? So once we execute this line, 5 is assigned to the my variable 1. So my variable 1 is already overwritten, right? So 10 is gone. No 10 here. My variable is become a 5. So here, 5 is goes to here. So in the end, my variable 1 and 2, they're all 5 assigned to these two variables. So this is not correct statement. Okay? Does it make sense? So to figure out this, to solve this problem, we introduce another variable. It's named TMP. It means it's like a temporary variable, I would say. That's why naming is TMP. So you first assign the value inside of my variable 1 to temp, and then you're overriding the my variable 1 using the my variable 2, and then assign the temp value inside of the TMP to the my variable 2. Then you will see this one. Okay, this is the the typical way to swap the value. Make sense? Okay. Maybe you could write a script like this: temp 1, my val 1, temp 2, my val 2, my val 1, temp 2, my val 2, temp 1, right? But it works as well. But this code is shorter than this one. For me, this one is so much readable. Okay. By the way, here, what is this semicolon? Okay. Without this semicolon and then run, you will see that some value inside of the variable is printed out in the command window. So if you see the MATLAB, this one is a script window. Here's the workspace. Here's the command window. So if you run this without this semicolon, you will see that many things are printed out. Okay, the values, this value is corresponding to the value inside of the variable. So unless you want to check the value inside of the variable, and I recommend to put this semicolon at the end of the line. See this? You can put the comments after this semicolon. Okay, meaning that this text is ignored when the script is executed. Okay, good. Okay, so next topic is the data type. Every expression and the variable have associate type or class. Human don't pay attention to the size of the number, but the computer must do so because it has allocated memory to hold the number. Thus the type is important in every programming language. To understand the type, I would say the type or class is considered as a container. Okay? If you define the integer value, 1, 2, 3, we don't need to huge bin, huge container. But if you're dealing with a large number or large decimal points, like 2 points or 145 or something like that, you will need a bigger bin, bigger container to represent this high precision numeric value. Okay. Another type is logical. Logical is only contained yes or no. So logical, yes or no. Then you can also represent it as a logical 1, logical 0. Okay. That's why in this case it takes a very small container. Okay. Another type is a character. Character is a single letter. Okay, how to define this character variable? You're going to use this quote. So for instance, character val equal to a. This script is indicate that this character value is assigned to this variable. Okay. The string is a set of the character, is a sequence of the character. You can use the double quote. We'll revisit this one is, I guess, a module 9 or 10. Okay. So MATLAB, the default type for the numbers, the numeric value is a double. So the default is a container, is a big. So you don't have a risk of the numeric errors or overflow. But what is the drawback? If you handling with this bigger container, big containers, you need to have a larger storage and then slow the processing speed. Okay. To improve the speed of your code, you need to consider is the data type. But we are the beginner, right? At this point, you don't need to consider this numeric type. For instance, integer or the unsigned integer. You don't need to consider this one at this time. Okay. You only remember double, logical, character, and this is a string. String is we'll learn about in the module A. Okay. So here's the example. Class is a function of the determining a class of the object. Okay, what is the function? Let's go to as I mentioned, there are lots of the built-in function in MATLAB, and also you can make your own function. To use the function, you call it with an input argument and pass this input argument to the function and return the output. So here's the syntax. Here's the function. There are lots of the function in MATLAB. So you put the input argument here. Then the output value is assigned to the output variable. Is a variable here. So here in this case is out is the variable name. For instance, I'll say, let's say val equal to ABS. ABS is computing the absolute value. In this case, inside of the val, the 4. Because absolute value of the minus 4 is 4. Okay. So go back to the, slide 20. So class is the function to determining the class of the object or variable. So if you put so in this case, this one is a string. So class type is a string. These are the character. That's why if you run this script, it will say the character. True. What is a true? I didn't mention that true is another constant. Inside of the true, that is a logical 1. Okay, logical 1. Okay. And then false is also constants. Inside of the false, there is a value of the logical 0. Okay. I mean, in the true, the 1 is assigned, but these types of the 1, types of this numeric value is the logical. Okay. This is a logical variable in the workspace, there is a mark as a 1 or 0. But this 1 or 0 is not a numeric value. This one is a logical value. Here's the thing. The class of the 2.145 is the double. That makes sense. What about the class of the 10? That is still double. Why? Because default type for number is a double. Unless you change the types of your numeric value, all the numbers are the double type. Okay. Okay, so here's some challenging topic. Typecasting. Okay. There are many functions that convert the value from the one type to the another. Okay. The name of this function are the same as the names of the type. The names of the name can be used as a function to convert the value of that type. So basically, there's a function to change the types of the variable. But the name of the function is the same with the type name. Okay, this is called the typecasting. Okay, let's take a look at this one. Okay, so here 1 is a number, right? Number is always double type, right? So logical is a type name, right? But here it say type name, the function to converting this from one type to another, the function name is the same with the type name. So if you run this script, the logical 1 is assigned to the A. Because the 1 is a number, is a number, default type is a double. This process is to converting the double type value to the logical value. Okay, that's why the class of the A is a logical. I would say this one is a challenging. So I'll keep revisiting this topic, in the future. Okay, here double is the function to convert input types of the input to double, right? Okay, so if you run this script, you will see, so the B become a double. Okay, does it make sense? Okay, this one is much more tricky. Okay. Okay. So I defined the A variable and assigned the logical one. Okay. What happens if we run this script? B is equal to A plus 2. Okay, in this case, A is a logical one, right? Logical value is a true, right? So how to compute the logical 1 plus 2? That is called implicit, typecasting. Meaning that the types of the value is implicitly changed to the double. Here is a double, but it's a larger container. So in this case, A is a 1. 1 is a logical, logical type. But when you run this script, when you run this expression, 1 become a double type. That's why A plus 2 become a 3. Okay. All right. So here's another thing. What about the logical B? Okay. B is a double. Okay. How to convert the double type to the logical type? The rule is here. Here. Non-zero double value become a 1. Otherwise, a 0. So logical 3, 4, 5, 6, or whatever numeric value except for 0 that become a 1, logical 1. Otherwise, a 0. Actually, this is a very important concept in the logical operation. But I'll stop for explaining this one here because we keep revisiting this topic later. Okay. All right. So we're going to talk about the operator. Operator is the symbol to compute the value. There are two types of the operator: unary operator and then binary operator. Unary operator which operates on a single value, but the binary operators you need to have a two value in between the operator. It sounds like they're tricky, but they're very simple. If you take a look at this one, plus operator. How to use a plus operator? Like this. You need to have a two value, right? 5 plus 1 is a 6. That's why the 6 is assigned to the variable 1. What about this one? The star is a product. Okay, 10 times 2 is the 20, right? 20 is assigned to the variable value 2. So this had exponentiation. Okay, so this means 10 power of the 2. So 100 is assigned to the value 3. This one is a divider. 100 divided 5 become a 20. Okay, that's very easy, right? So what is a unary operator? These are the unary operator. Negation. Okay. To represent the minus 3 using this operator, we don't need the 2 value, right? Okay. All right. Some operators have a precedence over the other. This is very similar to the mathematical symbol precedence order. So like a parenthesis, a plus and minus is a multiplication. For instance here, what about this one? 12. Everyone know that, right? Because the expression inside the parenthesis is a round first, that become a 6. 6 times 2 become a 12. What about this one? Okay. We should do this operation first, right? So, I mean in the mathematical equation. So 100 times 3 become 300. This one is this is a 5, so this is 100,000, right? Okay. What about this one? If you see this one, so negation, exponentiation. Exponentiation is around first, so this become a minus 100. Okay. Here's a very simple, the example. You can easily, compute this one. But what about this one? Is a 6 power of 1 become a 6. Okay. That's easy, right? Okay. Okay, so relational operator. Relational operator is to relate the two expressions left and right hand side. This is the operator. This is also operator, okay? Like a plus and minus, okay? And the output of this operation is a logical value. For instance, let's say greater than 3 greater than 4. The answer is yes or no, right? That's why the output value, the types of the output variable, types of the output value is a logical. Okay. Also here, this is the equality. This is not equality in MATLAB. This is equality. Okay. For instance, the 3, if you run this script, what is the answer? False, right? Or a logical 0. Okay. Does it make sense? Okay. Don't confusing with this equality sign and then just equal sign. Okay. You consider this operator is similar to the operator that we saw in the previous slide. It's a numeric operator. Okay. Let's go to the next slide. Let's see this example. What is the answer? True. Okay. If you see this the variable in the workspace, you will see this 1 or 0. But here, 1 is not the double type. 1 is the logical type. Okay. 1 means true, 0 is a false. Okay. After this one is a false. Oh, one thing. These are the inequality sign. Means not equal. Okay. So here, 3 and 7 is not equal, right? That's why arrow 4 is a true. Okay. Does it make sense? Okay, good. The concept itself is easy if you if you use this a single operator in expression. So logical operator is the operation between the logical value. What is the logical value? True or false, right? So there are or and not. There's one more XOR, but I'm not going to teach this XOR. Okay? These are three operator is a commutative, meaning that 3, 4, I don't know. True, false is the same with the false, true. Okay? Here's the output of the operator. Because the OR operator, the expression is a true if at least one true exists in the X or Y, otherwise a false. So take a look at this column, this one. Okay. When the X is a true, Y is a true, X or Y is a true, because there is at least one true, right? This one is also true. Why? This one is a true. But X, Y, both X and Y's are false. These are the false because there's no true, right? Okay, so what about the AND operator? AND operator, the expression is a true only if both are true, otherwise a false. These are, both are true, that's why true, otherwise these are the false. Okay? Not operator is just giving you the opposite answer. So true, not means false. Not false means true. You know, that's simple, right? You can only remember, you just remember this operation, and, or, and not, okay? Okay, let's just see example. This is the AND operator. True and false is the false, because AND operator, so both are true, only the both are true is a true, right? See this? AND operator, both true are true, otherwise a false, right? These are true because this is OR operator. These are false. Why? None of the, none of the variables are, none of the values are true. Okay, what about this one? So, okay. 0 or not false. Not false means true, right? 0 or true means true, right? This is quite simple, right? I understand you're confused why we learn about this simple thing, right? You don't have an idea how to use this logical operator. But I'm telling you, this is extremely useful. Okay? This logical operator, concept of the logical operator is very important in MATLAB. You will see this value because I'm actively using this logical operator to solve the tutorial problem, and then there's so many problem in your quizzes and homework assignment. Okay, I'm giving you one challenging question. Okay, What about this one? What happens if I run this script? A equal sign, not 3. This tilde is a not sign, right? What is the not 3? Okay. Here, the logical operator is take the input of the logical value. So, first step is 3. That is the double type, right? All the numbers are double type. Is the default type is a double unless you convert the the types of the your value is a number, right? So double type. If you want to use this tilde is a logical operator, first this value is converted to the logical value. That is 1. Okay? All the value are 1 except the 0, right? Only the 0 is logical 0. So it is evaluating the not logical 0. This is a not false. Okay, so not false means a true. So true is a sign. No, sorry. Sorry. This is wrong. So these are the true, right? 3 is all the numeric values are true unless 0, right? Otherwise, the values non-zero values are all true, I would say. Okay, so this one become true. What is the not true? False. So false is assigned to the A. False is equal to logical 0. Okay. Good. Okay. Another challenging topic is general operator precedence. Again, this one is operator, this one is operator, this plus minus product is all the operator. So there are precedence between this operator. Okay, I know it's a bit hard to wrap your head, but you consider all these are the operator. Okay, and then compute the value with this precedence order. Okay, let's take a look at the example. What is the value assigned to the value 1? Here, the highest precedence is the parenthesis, right? So this become a 4. So you're evaluating the 3 less than 4. That's why it become a true logical 1, right? What about this one? This one is 3 is less than 1, right? This one is false. Logical 0. So this then perform the logical 0 plus 3. So logical 0 is converted to the double 0. So this become a 3. In this case, this one types is a double. In this case is a logical. Okay. What about this one? Okay. Here, if you see this table, plus is a higher precedence than the relational operator. So this one is evaluating this one, comma 1. But I don't recommend this types of the script because sometimes it's very confusing, right? So I recommend to use the, you know, these types of the parentheses, because the parentheses hides the precedence, right? Okay. Again, the reason you're confused with this kind of the, you know, the equation is that this is not a normal math equation, right? Okay. But you know, this one is a script. It's not a math equation. So computer interpret and compute this expression following to the operator precedence rule. This is a programming that run based on the rule. Okay. Let's take a look at this one. So what values are assigned to the variable? In this case, this one is a 0, right? No, 1, right? Okay. 1 is a less than 4. This is the true. So 1. Again, this one is a logical type. This one is the 4 is a less than 5. True. 1, right? 1, 3 is less than 1. That is 0. False, right? False. Okay, here I'll repeat it again. In this case, this will produces a 0. Oh no, 1, right? But that is a logical. But relational operator is to take the double, you know, the numeric value, not the logical value. That's why 1 is converted to the numeric value. In this case, it's double type. Okay, that's why it's a 0. Okay. What about the LG4? This line. Okay. 10 is larger than 4, right? So this one is true. And 4 is larger than 1. There is a true. So this value become a true. So logical 1 is assigned to the LG4. Okay. Okay. All right. Yeah. This is an example. So many students are confused. Okay. How to write a code to check if x lies in between the 5 and 10. If yes, 1 is assigned to the variable. Here is this one is logical 1. Otherwise, a 0. And many of the students is tempted to write a script like this, right? Because it is a mathematical equation, right? To represent that x lies in between the 5 and 10. But these are the completely wrong. It's totally wrong. Okay? Why? Let's see this example. x1 is become a 6, right? Then you're evaluating this one, right? Okay. So you evaluate this one first. 5 is less than 6. That's a true, right? 1 is less than 10. That is a true. right? But the answer is correct. But let's take a look at this one. No matter what the value is, let's say you put the 100 or the 10,000 or 0, whatever value, this first operator, this expression using this operator, produce 0 or 1. Meaning that if you run this script, 0 or 1 is always less than 10, so this gives you always true. Okay? Meaning that it's a completely wrong script. Okay? Does it make sense? So basically, the correct approach is you can make the two different statements. Okay? The fact that x is in between the 5 and 10, it is x is more than 5, right? More than 5. More than 5 and x1, x is less than 10, right? So that's why this one is the correct script. Okay. Again, so x is lies in between the 5 and 10 indicate that x is more than 5, right? And x is less than 10. Okay? So these are the correct script. Okay? Does it make sense? Okay? Good. This is a very important. If you understand this example, you understand the operator precedence. Okay? Okay, important. All right. We already covered this function, right? Let's learn about some basic math function. These are the rounding function. Rounding function is to map a real number to the integer number. There are 4 different ways to do this. Round is to map the number to the nearest integer. Okay? Fixed is a nearest integer toward 0. Okay? Here's a minus, here's plus. Plus. Floor is the nearest integer toward the negative infinity. So this direction. Cell is toward positive infinity. Okay. Okay, let's take a look at the example. Okay, so let's take a look at this one. Okay. Here. Okay. Round is the nearest integer. What is the nearest integer? 0, right? What is the nearest integer toward a positive infinity? It's a 1, right? Fix is a truncate x to the nearest integer towards 0. 0, right? Floor is the nearest integer, is a negative infinity. That is 0, right? Makes sense? Let's do this for minus 0.6. Okay. Round is nearest integer is minus 1, right? So nearest integer towards 0, that is a 0, right? Nearest integer toward a negative infinity. Oh, there is negative infinity, so minus 1, floor, minus 1 is here. So nearest infinity toward the positive infinity. Positive infinity is a 0, okay? Does it make sense? All right. So this is another, the example. Okay. I think you can understand the, how you compute this value from this script. Okay. These are the, the common math function. Compute the absolute value, compute the square root of your input. This one is finding out the sign of your input variable. These are the remainder when the x divided by the y. In this case, it takes 2 input, right? Input argument. For instance, 25 divided by 4 is 6, and remainder is 1, right? What about the 4, 2? Remainder is 0, right? Okay. That's easy, right? Okay, let's take a look at this one. Remainder of x is a minus 4, z is a 2, remainder is 0. Okay. What about the square root of the y? Y is 9. That is 3, right? Okay. You can find out the sign. What is the sign of the x? Minus. So you can see the minus, right? Okay. So there are function versions of the logical operator. So the output of the a and b is the same with and a and b. A comma b. Okay. So these are the produce the same value. Similar to the or and not. But the question is, why do we use this function? So when do we use the operator? The good thing of the function is, if you see this one, if you list the many operator in one line, it's not obvious what the process of this expression. But if you use the and, it's much more readable, right? It's much more clear, right? Okay. Good. Okay. Before closing the module 1, I would like to explain the random number. It'll be used in all your MATLAB grader problem. MATLAB can generate the random number. Actually, it's a pseudo random number. It's a fake random number. Why? Because the MATLAB just read the random value generated in advance. This is basically, there are many random number table in MATLAB, and then each table has a seed number. Okay, I mean kind of the index. Okay, kind of the ID. Whenever you generate the random number, the seed is assigned, and then read the value on your random table. But this seed is generated from the time information. It's a clock information. That's why whenever you run the random number, you will generate a different number because the time is keep changing, right? Okay. Does it make sense? Okay. Okay. Here's some built-in function to generate the random number. So Tn and I will actively use this random number to make the autograded problem. We haven't, learn about the matrix, but the syntax of this function is random n is a create n by n matrix, and then the real number in the interval of the 0, 1, and this one is a create n by n matrix of the random real number, and this is a I is a generate integer number, so you can specify the range here. For instance, ran I 0, 10, 1 means you can generate the single number between the 0 to 10. Okay, and our range seed is a specified seed for random generator. Okay, this is kind of optional, but because this helps to, this ran. This one is optional. We are not using the ran the rest of the the course, but it helps to understand how the random number works. Okay, but let's take a look at this example. Ran 1 is a generate one single random number. I run it, generate this number, and run it again, and then you generate this number. So these are the different. Why? We read the the random number in the different random table because the seed is changing based on time. Okay, so this orange seed is a specified seed for a random table. So if you run this means, oh, you need to read the 10 seed number random table. Okay, then you generate the number, you run it again, you will get the same number. Okay, this is how the random number works. So I'm going to give you some kind of the tips. Okay, let's assume that you're going to compute the value of the y when the x is equal to 10. Okay, then you write the the equation like this, right? But if you take a look at this one, it's hard to evaluate. If you make one single mistake somewhere here or there, it's hard to fix that, right? What is the better script? So I recommend that you can write a script like this. You can define the two different variables, denominator and numerator. I think that this one is new, should be the new, but anyway. And then you can write the script using the variable that you define. Then you can easily find out the the errors on your script if you made a mistake. So I would like to tell you that when you write a script, you write a script in such a way that you minimize the the mistake. Okay, so this is a good example. So sometimes I write the the long line because that is more readable rather than to separate them. But sometimes it's separating this line is better by introducing the variable. Okay. Okay, this is the last slide. I would like to finally mention the fundamental question of why we are using the programming tool. Okay, for instance, here's an example. Suppose that you're solving the problem like if the car has a mass of 300 kilogram and you push the car with a acceleration of the 5 inch per second. Oh, 2 per second. Okay, it's my mistake. Compute the force that is generated from the car. This is simple physics, right? F is equal to ma. Okay. I'm asking you to solve this problem, the MATLAB. Some people write a script like this. Okay. I would say the students use the MATLAB as a calculator, not the programming tool. Okay. The better way to do this is like this. You can use the mnemonic variable name and assign the value. Then you can figure out the meaning of each value here, right? You can put the comment, oh, this is inch to meter, right? So it's like a unit conversion. So if you see that, so this is a variable is explain the what is the value inside, right? So you can easily understand your process, right? And then to compute the force, you're using the variable like this. Okay. Writing the script like this is improve the code readability and allow the others to understand your code. Also, when you revisit your code, let's say you revisit your script, after a year, can you understand this script? No. Okay. Okay. Good job. So that's it. This is all for the module 1. Please solve the tutorial problem in MATLAB Grader. Then watch my tutorial video to check my model answer. Okay, thank you guys, and see you next lecture.